Welcome, I am Grace Chen, and today I will be introducing the topic of limits of a function. A quick review of what limits are. Finding the limit is finding what number the y value approaches when the x value is approaching a number c. When f of x is continuous at the point, then it is simple. The limit is just whatever f of c is. But what if the graph is discontinuous? Well, as long as it is a removable discontinuity, the limit still exists. If it is a non-removable discontinuity, the limit doesn't exist. So remember this. As long as both sides approach the same number, the limit exists, regardless of whether the number is defined or not. Now, it's easy to tell what the limit is on a graph, but let's look at how to find the limit algebraically. Sometimes it's as easy as plugging in the number into the equation. Never discount that. Other times, it can be a little trickier. If you plug in the number and you get a 0 on the bottom, then there are two cases. One case is if you have 0 over 0. In this case, you haven't simplified enough. Some ways to simplify are factoring, simplifying complex fractions, multiplying by the conjugate, etc. If it still can't be simplified, the last resort is plugging in values. Likewise, if you get a number over 0, in that case you have to plug in values very close to either side of the x value to see what it approaches. Here's an easy warm-up. If you try to plug in the value 2, you see that you get 0 over 0. So now we start simplifying. Most times when there is a polynomial, factoring will be the easiest way to simplify. So if we try factoring the top and bottom, we can see that the x minus 2's cancel out, and from there you can plug in 2 for x to get 2. Now here's another problem that's a little harder. Plugging it in, we see we get 0 over 0 once again. Now with rational functions that have a radical, a lot of times multiplying by the conjugate is your best bet, so we can multiply by the conjugate of the denominator. If you follow through and simplify, you will also get 2 as your answer. Pitfall. Be careful not to think that when you have a square root of x squared plus 3, that it can be multiplied by the square root of x squared minus 3, because with a conjugate, the number always has to be on the outside of the radical. Limits from the right or left. Sometimes, the question will ask you to only evaluate what the limit is from one side. For example, in the following graph, the limit as x approaches 2 from the right is 5, but from the left is 1. Therefore, the limit overall at 2 doesn't exist, but it does at either side. We'll do more of these problems later on. Next, we can use limits to tell us about the asymptotes of a graph. You have a vertical asymptote when the limit goes to infinity or negative infinity, but both sides of the graph have to go towards the same direction in order for the limit to exist. To solve for these, go through the same steps as you normally would. Here's an example. As you can see, plugging in 0 gives you a number over 0, so you know all you can do is plug in numbers. Plugging in a number on the right side of 0 will give us 6 over 0.001, which is a very big positive number, basically infinity. If we do the same thing on the left by plugging in negative 0.001, we get positive infinity. So we know the limit overall is infinity. Sometimes the question will ask you to find the limit as x approaches positive or negative infinity. This means it is asking you for the horizontal asymptotes of the graph. To solve for these, all you have to do is find the end behavior, but another video will go more in depth about that. Another pitfall. Make sure to write the limit symbol before each step until you actually evaluate the limit so that you get full credit. Limits with absolute value. When doing limits with absolute values, first write the absolute value part as a piecewise function. Then choose the part of the piecewise function we are evaluating to use in the equation. Finally, simplify and solve. In fact, this is true for any piecewise function. In this example, we see that because it is asking for the limit from the right, we should use the positive version of the equation. Then, we can factor out the bottom and cancel out, giving us negative 1/4. Pitfall number 3. Make sure you are using the correct part of the piecewise function, and beware that they can trick you by defining a point that would have been a hole or giving it a different y value than what it would have been if you had plugged it into the equation that's the other part of the piecewise function. Here are some handy trig identities involving limits that you should all memorize. These come in handy when you're trying to prove things or when simplifying or solving for other limits. The limit as x goes to 0 of sine of x over x is 1. The limit as x approaches 0 of 1 minus cosine x over x is 0. Here's a quick recap. Remember, the limit exists overall if x from both sides approaches the same number. Sometimes they won't approach a number, however, but positive or negative infinity. This means that there's a vertical asymptote. If both sides don't approach the same thing, then we use the term the limit does not exist. However, sometimes the question will only ask you what the limit of a function is on one side. To do this, follow the same steps as you normally would, except if you have to resort to plugging in numbers, you only have to do it for the one side they are asking for. Here are different types of questions that are most common: radical, rational, quadratic and polynomial, and absolute value. Finally, if you plug in the value and get 0 over 0, you know you haven't simplified enough. If you get a number over 0, start plugging in numbers. Thanks for watching!